In this lesson today, we're going to talk about dependent probability. So dependent probability is something we like to use the terminology without replacement. So unlike independent probability, we're actually going to take the object out and we're going to leave it out of the batch that we have. So the probability, the dependent probability is when the probability of one event occurring, it actually does affect the probability of the other event occurring. So it's kind of like a little ripple effect. Let's look at the first example. I'm sorry to try to, I'm not trying to make you hungry here with all the candies and donuts, but I thought this was a great way to explain this example. So there are 5 donuts in a box. We have 2 glazed, we have 2 sprinkled, and we have 1 cream filled. What is the probability that you'll randomly select a glazed donut, eat it, and then randomly select a cream filled? So you have to kind of understand what's going on here. You pull out a glazed and you eat it. That's going to change the number of donuts that you have to choose from the second time around. So let's go ahead and calculate this. The chances of me first going in and randomly selecting a glazed donut is, well, I have 2 glazed donuts, so it's going to be 2 out of the 5 that I have. But now, since I have eaten one of those glazed donuts, it no longer exists. So now I have 4 to choose from. I want to know, what are the chances that I go in and I pick a cream filled? Well, there's only 1 cream filled, so I'm going to choose 1 out of, there's only 4 options to choose from. See what happened here? My denominator changed. So now that that's happened, let's go ahead and calculate. Now, I taught you a little trick during independent probability, and now I want to kind of expand on it. Remember, we talked about when you're simplifying a fraction, you can simplify it before you actually calculate it. This is something a little bit new now. Do you notice how the 2 in one fraction in the numerator and the 4 in the other fraction in the denominator could actually simplify? I could actually simplify 2/4 diagonally. I'm going to show you how to do that. So I'm going to take the 2, and I know that 2 and 4 are both divisible by 2. So I'm going to divide this 2 by 2. That's going to give me a 1. I'm going to divide my 4 by 2 as well, and that's going to leave me with a 2. Now, there's no more simplifying that I need to do. I can go ahead and multiply my fractions straight across. 1 times 1 is going to be 1, and 5 times 2 is going to be 10. So the chances of this actually happening is about 1/10. So 1 out of 10 times this could actually occur, which is about 10%. Okay, let's try another one. We're still looking at the same box of donuts. We have 2 glazed, 2 sprinkled, and 1 cream filled. This time I want to know, what is the probability that you'll randomly select a sprinkled donut, eat it, and then randomly select a glazed? So let's do the same thing here. What are the chances that I'll randomly select a sprinkled? Well, I have 2 sprinkled out of the 5 sprinkled donuts in my box. But now I have eaten one of the sprinkled donuts, so I don't have that donut to choose from anymore. So now if I go back into the box and I randomly select a glazed donut, well, I can see that I still have 2 glazed donuts to choose from. So I'm going to be able to choose from 2 out of the 4 donuts that are left. Now let's simplify. Again, we have a unique situation where we can either simplify diagonally or we can simplify up and down because 2 and 4 are divisible. So let's go ahead and divide it by 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. Now, this is kind of cool. Pay very careful attention. Do you see how that left me with a little 2 down here? Do you see the 2 in the numerator and the new 2? Well, I can actually simplify both of them. 2 divided by 2 is 1. 2 divided by 2 is 1. Simplifying this all the way down. Now I don't have to do any simplifying when I'm finished. So my numerators are 1 times 1 is 1. And my denominators are 5 times 1. I'm going to use this number. 5 times 1 is 5. So you can see that the chances of this actually happening is a 1 in 5 times, which is about 20%. So this is a little bit more likely of this situation occurring than the other. Probably because we have 2 donuts to choose from the second time versus our 1 cream-filled donut in the first example. Let me show you 2 more. Okay, now I'm going to be kind of teetering back and forth between independent and dependent. I want to show you the difference between the 2. Let's look at the first one. Let's say that if you select 2 candies at random and replace each one back into the bag before selecting the next candy, find the probabilities of selecting them in the order listed below. So, looky here. We have 4 Tootsie Rolls and we have 2 Tootsie Pops. That's giving us a total of 6 candies. So we want to know, what are the chances of us rolling a Tootsie, or not rolling a Tootsie Roll, but selecting a Tootsie Roll and then selecting another Tootsie Roll. But the big key thing is that after we select the first one, we actually put the first Tootsie Roll back. So let's talk about it. The first chance, or the chances of us going into the bag and selecting a Tootsie Roll, which is this guy right here, would be 4 out of the 6 times. Now, let's say that I pull out a Tootsie Roll and I look at it and I don't want to eat a Tootsie Roll, so I put it back in the bag. Now I want to know, what are the chances of me pulling another Tootsie Roll? Well, it's still going to be 4 out of 6 times. So I'm going to go ahead and multiply them. 4 and 6 can be divided by 2. So if I divide that by 2, I'm going to get 2, and I'm going to get 3. Same thing for my other fraction. It simplifies to 2/3. Now I can multiply. 2 times 2 is 4. 3 times 3 is 9. So the chances of that situation actually happening is going to be about 44%. Now let's look at the same situation here, exactly the same, but let's say that we don't replace it this time. We actually take the first Tootsie Roll and we eat it. So let me read it. If you select 2 candies at random without replacing each one back into the bag before selecting the next candy, find the probabilities of selecting them in the order listed below. So without replacement, what are the chances of pulling out a Tootsie Roll? Well, it's still going to be 4 out of 6 chances of selecting that Tootsie Roll. But now we've taken the Tootsie Roll and we've eaten it. So now what are the chances of us pulling another Tootsie Roll out? Well, we've already eaten one of them, so that means that there are only 3 left in the bag. It also means that the total number of candies in my bag decreased by 1, giving me a denominator of 5. At this point, I'm done. I can do my simplifying. So 4 divided by 6 can be simplified to 2/3. You can see that my 3 and my 3 diagonal from one another, they can also be simplified as well. 3 is divisible by 3, and 3 is divisible by 3. Now all of my numbers are simplified. 2 times 1 is equal to 2, and 1 times 5 is equal to 5. So my probability of that situation actually happening is about 2/5, which is approximately 40%. So that is the difference between replacing and not replacing. You're always having to think about what's going to happen to the denominators of the pieces of candy. And that's all we have for dependent probability.